Okay, so this is Algebra 1, Lesson 3.3. The question we're going to tackle in this lesson is how hot is Earth's crust? And the temperatures within the Earth's crust can get hot enough to melt rocks. And we're going to use a multi-step equation to figure out how to predict the depth at which the temperature of the Earth's crust is 114 degrees Celsius. And the one thing, when you're solving a linear equation, it requires more than one step. Thus, the title of this lesson is Solving Multi-Step Equations. So let's look at this problem right here. We have 3x plus 7 equals negative 8. And what I did here was on this first line, I wrote out the original equation. Okay, and then on this second line, I've subtracted 7 from both sides, so we have negative 7 and negative 7. Now we need, and we're left with 3x equals negative 15. And remember that negative 8 minus 7 is the same thing as negative 8 plus negative 7. So we end up with negative 15. Now we are going to divide by 3, and that will take care of the 3 there, and then we end up with x equals negative 5. Now we need to check our original equation and see if it works out. That will be negative 15 plus 7, and that will be negative 8 equals negative 8. And so in this case, we have solved a linear equation. And the other thing is, when you have a word problem, is to use a verbal model first and then to label it and then do the algebraic model. So let me go through that. Okay, so the temperature within the Earth's crust increases about 30 degrees Celsius, and I can't figure out how to do the little degree sign on this yet, so I'll have to write out the degrees for each kilometer beneath the surface. If the temperature at Earth's surface is 24 degrees Celsius, at what depth would you expect the temperature to be at 140 degrees Celsius? And that may seem kind of like a lot here, but I'll show you how to set something up like this. So let's set this up. What we do know is that the temperature inside the Earth is 114 degrees Celsius. We know that the temperature, and so that's a given. We already know that that's what we're after. The temperature at the Earth's surface is 24. And we know that the rate of increase, which was up here, increases 30 degrees Celsius. What we don't know is the depth, and so we don't know D. We can plug in, so we already have our, by doing the verbal model first of what we do know, and then plugging in the numbers, we can then start to solve this. So the first thing to do would be, I want to change colors here, to take away the 24 from each side. That will leave 90 over here, and over here we have 30 degrees and the D. And now we can divide each side by 30. I'm running out of room, so I'm just going to do it like this. And that will leave us 3 equals D. And so we can say that the temperature at 114 degrees Celsius will be at a depth of 3 kilometers. So let's look at another example. If the temperature at Earth's surface is 24 degrees Celsius, again, I can't get the little circle to work on here, so I'm using a little d. At what depth would you expect the temperature to be 174 degrees Celsius? And you can use the example that we just used to solve the problem. So to solve this, I set up my verbal problem first. I'm going to write it with the verbal model. I have the temp inside the surface, which it says right here is 174 degrees Celsius. I have the temperature on the surface, which is 24 degrees Celsius. I have the rate of increase, which I knew from the previous problem was 30 degrees Celsius per kilometer. And I don't know the depth below the surface, which is what it wants to find out. So that's the unknown here, and that is what D represents. I can now solve my problem. Or let me rewrite it correctly. (30D) in algebraic form. And let's see, let's subtract 24 from both sides. Oh, I left off the plus 24 that was already there. So this is what I'm doing on each side. That crosses that off, and this leaves 150 there, equals 30D. And now I need to divide by 30, and I end up with 5 equals D. And then I can put that back into the problem, and I would end up I don't want to do that. Sorry, ignore that. I want to rewrite the problem here, and so the answer is 5 kilometers. But I could put it back in and it should work out fine. Okay, so we're going to use the distributive property here, but I want to quickly go over the properties and just some little math ways to remember it. So if you remember, the commutative property means you can change the order and it'll be the same. Associative property means that if we group them with parentheses or whatever, that you can change that the order there and it's okay. And distributive property means that we can spread it out. So for example, so I can have 2 times x plus 7, and I can spread this out there, there, and there. I can spread it out and solve it. If you have 8x minus 2 times x minus 7 equals 16, we need to distribute the 2 out of there. So you would have 8x minus 2x minus 2 times 7 equals 16. Make sure when you distribute the the negative to both the x and the 7. So then we can simplify this a bit. Okay. And we can go a little farther. Now we can add, add 14 to both sides. We have 6x equals 30. Divide by 6. And you're going to end up with x equals 5. So in this case, we were distributing a negative number. Let's do it with a positive number. Okay, so I am distributing, working with a positive number with 5x plus 3x plus 4 equals 28. I distribute it here. Now I'm just rewriting it algebraically, and I can start simplifying. Can get rid of the 12. That leaves 8x equals 16. Divide by 8. And you're going to end up with x equals 2. So here we want to use the distributive property and to combine like terms. We have 6 times x plus 2 equals 15. We will distribute it. So we'll have 6x plus 6 times 2 equals 15. That is 6x plus 12 equals 15. Subtract 12 from both sides. We end up with 6x equals 3. Now we want to divide both sides by 3. We end up with x equals 1/2. Oh, sorry, I wrote down the wrong number. I'm sorry, hang on. I wrote down, it was 6. I wrote down 3. I wasn't paying attention. Okay, and then you have 1/2. And you can go back and check and make sure that it works out, and it does. So we end up with 15 equals 15. Okay. I want to show you this one, and I'm going to do it slightly different, not to confuse you, but to show you something. So let's say we have, I'm just going to rewrite this original part here, but I'm going to go ahead and get rid of my 8 here. Oh, see, I wrote it's a negative, because this one right here is this is a positive, and so this one needed to be a negative, and I need to subtract it over here. Now I've gotten rid of that one. Those two cancel each other out. These two cancel each other out, so that's a 0. Now I'm left with a negative 4x plus 1. And I want to, instead of distributing this, I'm going to go ahead and divide both sides by negative 4. That cancels this out, and I end up with x plus 1 equals 0, because negative 4 into 0 is 0. and then I can get rid of the 1. Hang on so I can get the red. And now these are canceled out, and I have x equals -1. I did that slightly different, but it works out. And then you can go back and check your answer to see if that is the answer, and it is, so we're in good shape. This one I'm going to do it, let's see, we have 3m plus, I'm going to distribute this. Oh, sorry, that's 2, 5 equals 10. That will, so I got like terms here, but I want to, let's see, let me just go ahead and solve. Keep going here, so now I can add to both sides. These cancel each other out. Divide by 5. And m equals 4. And you can go back and check that in your original to make sure that that is the right answer, and it is. Okay, so this one we're going to multiply by reciprocal first. We have 4 equals 2/3 times x plus 3. I use my reciprocal right here and right there. And then, so I've multiplied both sides. I can work that out. That would be 12/2. These cross each other out. That is 6 equals x plus 3. I can get rid of the 3 here because I want to isolate the x, and subtract 3 here. End up with 3 equals x. Okay, your assignment is 3.3. For 3.3 is on pages 147 through 149. Exercises 25 through 27, 34 through 36, 41, 45, 46, 53, 54, 50, and then 56 through 74 even, and quiz number 1 on page 149. Again, write these down on your answer sheet so you can remember the problems. And both, if I've put these two together, which then they're both due by class time tomorrow.